And by integrating AI-driven capabilities into distributed infrastructure, operators can deliver smarter, more adaptive services, reduce latency, and support autonomous systems to personalize customer experiences. This session explores the strategies, architectures, and partnerships driving this shift. Joining us are Frank Miller. He's Chief AI Architect at Colt Technology. And next to him is Rishi Shukla. He's Vice President of Sales at APAC at Rakuten Symphony. And gentlemen, welcome.
Thank you.
Thank you.
Thanks for being here. Frank, this is our first time doing this. I appreciate your time.
Oh, no problems at all.
And Rishi, I've heard your name many, many times, but we actually haven't met in person. So.
Yeah, so I'm happy to meet you.
Absolutely. Yeah. Thank you so much. Frank, I'm going to start with you if you don't mind.
Okay.
Really talking about AI and that relationship between cloud cores and edge computing and in telecom networks. Can you kind of coalesce that for us and setting the stage?
Yeah. It's interesting because AI is following the same path that you've seen in public cloud. Remember, first there was public cloud, then depending on use cases and needs, came private or combined hybrid cloud. Really, it's the same thing that you see in AI workloads, right? Right now, it started with public, right? Especially on the training side with the inference being done in the public cloud. But the community is discovering that inference side, once you make the production models, really, depending on the use case, follows data gravity, so closer to the source of data, might have business needs like real time, for instance, sovereignty, could even be security. So I think telecom operators have a unique position to actually help enable this journey to hybrid AI.
Rishi, before I move on, anything to add to that?
Yeah. So if you see eventually what has happened that we were more on the centralized part of the architecture. So how the things have evolved in last decade is that applications are sitting more centralized. So a lot of intelligence and a lot of processing were there centralized. Now, when we come to the edge side, and that's what AI, driving that today. So there would be a distributed intelligence from the centralized to the distributed units, whether it can be a RAN site or an edge site or the MEC site, whatever with that. But the things how it is changing and shaping up is the redistribution of the processes, the redistribution of the workload, and then the redistribution of the intelligence, which was there centralized earlier, and now this is distributed. And that's how the things are shaping as far as AI, what was there on the centralized, and that's blurring the gap between AI at edge and centralization.
Frank, that's good segue. I wanted to ask you about the ultra low latency AI at the edge and maybe what some of those use cases are being impacted by that.
Yeah, so we've seen a couple of use cases specifically from our customers, right? We always listen to the customer voice. Colt as an operator, we're in about 32,000, business buildings around the world. We also have about 220, cloud connects. But that's really important to our customers who are running their training, building their models in the cloud. GPUs are expensive, but like you said, they want to push the inference as close as possible to ultra low latency. One of the use cases we've been asked for is literally a security. So visual recognition, camera, edge site, right? Could be a mine, you name it. So from a security perspective, that decision, that threat analysis, that, profile from inference should be right at the edge. Other ones, of course, are tied to IoT use cases. We get this a lot. There's a really interesting use case that's literally tied to creation of designer medicine, right? So you basically sequence your DNA. You can make a targeted cure based on your DNA, but that requires being near a CRISPR. Those components in a CRISPR, the proteins, are very sensitive. So if there's a latency issue, that yield could be destroyed. So we've seen all kinds of use cases from our customers.
Correct. So as you rightly said, right? So healthcare, I can see a prominent use case. And then from the MUR LCC perspective, where you require a very low latency, right?
Right.
And AR, VR, which is going to be the game changer. And I have seen that many operators are going and betting on the real-time gaming also, right? Which is cloud-centric. For that, things need to be at the edge side. And then I have seen a lot of problems on the security and the surveillance point of view, where you require, a lot of, data storage at the edge site.
Yeah.
And apart from that, being a Rakuten Symphony guy, what I can see and can see a change, a real-time network optimization and monitoring also would be driven as a use case as with the advent of AI in the edge sites.
Yeah.
So
Yeah.
that's also
Yeah, I'd like to add to that too. So you're exactly right. And the thing that's interesting is a lot of these real-time solutions, some of them are actually overlays, like maybe SD-WAN on a best effort, let's just call it a broadband network.
Correct.
We've actually been building literally an intent-based topology. Right. So we're also focused on folks who have ultra low latency. Depending on their needs, we literally can design for them an optimized path. And if you think about it, that's really a pretty complicated to do, to go through the topology, port by port, capacity, lambda by lambda, to make sure that we meet real time the latency requirements. And if we forecast or see it happening, we can reconstruct the actual physical topology. So I think that's another thing that is going to be required in the industry, that type of intelligent network awareness.
So, for example, autonomous car or remote surgery.
Yeah.
You require that.
Yeah, absolutely.
Yeah. Rishi, I want to go to you. Enabling seamless AI workloads across this edge core continuum. How do infrastructure providers and CSPs really collaborate there?
Yeah.
And how can that be improved, by the way?
Yeah. So first of all, if you see with the advent of the AI, what I feel that a lot of synergy is required from the infrastructure provider. Why I'm saying this, because it's a new ecosystem which is developing. It cannot be done by only the CSP or by the IP. So they have to have a conglomeration from the day one. So for example, if it is a simple RAN site, right? So it should be more hardware centric, right? It's a heavy server stuff and all. So a lot of hardwares are there. You required interoperability, and from day one, which we have seen, say spectrum, right? It is so much costly, right? That's what we have seen in last 3 decades, that whether it is 2G, 3G, 4G, operators have a tough challenge when it comes to the spectrum prices. Now we are building a new infrastructure altogether, which is more edge centric, and for that IP vendor has to come up with some sharing mechanism with the CSPs, so they should have a joint go-to-market as far as the sharing of hardware at the sites are concerned, so that they can build a sharing infrastructure. Secondly, ecosystem is very important in periphery, which can be developed by all the contributors who are working to make this domain successful, whether it is CSP, whether it is OEMs or vendor or the OTT player or the IP player. They have to come and make this ecosystem in a way so that it is not only the cost effective but also solve the end customer purpose. And third, and the most important thing, can we build because every site would be like a data center now, right? So can we build a common orchestration layer, right? Unified layer with the approach from all these players from day one. If such approach is there, then we have a good way to go and win-win situation for everyone.
And I think you're exactly right. So I think the change you're going to see in the industry is, originally when, let's say Rakuten, and Colt met somewhere, it'd be like an NNA to NNI exchange. That's not good enough. Both of us actually need a network as a service exchange with full, instantaneous self-service.
Correct.
So if we want to actually build circuits end to end, we cross each other's networks, right? You can actually have the intent and design to actually build that end-to-end experience for customers, and we both win. But also from the AI framework, if you actually see that there's an opportunity, share operational data from the API on the end-to-end experience, you could actually ask for a design change. There's one more future here that's really intriguing too, and we've done experimentation with it, where I don't know if you remember back in the old days with orchestration. You remember network orchestration, kind of glued in stuff. The hope is that it would be declarative. In other words, you just gave adjectives. I want this. The orchestrator could do it. It really never worked, right? But today with agentic frameworks and a good multimodal LLM on front, I think that hope is here. Right. So I think at the end of the day, the ability to give the intent across the NAS to NAS gateway in between innovators like Rakuten and Colt could actually do some really interesting stuff. Clear statements of what the customer wants. Let the agentic framework. Maybe there's even an agentic A-to-A interplay can actually manage the customer experience.
Yeah. I just want to get a top line challenge when you're scaling this AI inference and some of these model training at the edge. If you could just give us like one or two of those challenges just for the audience.
Yeah, I think at the end of the day, it's more holistic than that, right? So it's a little more personal to me. So being somebody who's like an engineer, you're an engineer, it's too tempting to build models that aren't efficient. So it's more than just having too much data. There's actually diligence that you use the least amount of information for the highest accuracy, right? So there's a whole lot of learnings to do here in the entire data science and engineering pipeline to make sure that you just don't have to listen to like 10 million parameters for 95% accuracy, right? I challenge, ML scientists, to actually do something with 5,000 parameters. And you're going to find at the end of the day, we don't always have to overbuild. There's gaps in performance all the way from just basic good, AI data science, which it's not an art, but it takes experience, right, for parameter engineering and feature engineering. The second one, of course, is architecture. The reference architecture needs a lot of work. And finally, it's silicon. So at the end of the day, from the capacity perspective, I still think there's a lot of maturity to come in the ecosystem, so we don't have to overbuild.
Certainly a lot of runway here to talk about this topic. We can talk about it a lot longer. I know that you need to get to the airport.
Okay.
I don't want to make you late, but I appreciate your time. Very interesting. Great setting the stage. I think this time next year we'll talk about maybe another iteration of this that'll be even more interesting. Rishi, Shukla with Rakuten Symphony, I appreciate your time and insight as well.
Thank you.
Yeah, thanks for being here.
Okay, see ya.